Hello, this is Prahashdeep Singh, and I will be giving a demo on how a PPG sensor works. So basically, we would be given a data, which would be the heart rate or the readings of the heart rate obtained by converting the analog signal to the digital one, digital analog heart rate to the digital signal through a sensor. We were given this signal in this experiment. This signal is defined by array 150. We are defining some global variables for this code. The global variables are L, which will be the window size of our moving average filter, and the data size, which is the data size of this array, of the given array, and a random variable means float variable. It would can be used in the mm, in the in the blocks to calculate and evaluate the signal. So first we start. So basically this experiment consists of many parts. These parts can be modulated as uh, first we uh, we pass the signal through a moving average filter, move f AF. Then we pass the signal to the first order derivative filter. Then we pass the signal to the moving average filter, and we check the peaks, and then we get the distance, which basically is the distance of our pulses, which gives us the pulse rate. So now moving on. So first we initialize all the contents of this array y150 y, or the contents of y1, which have 150 contents, to be equal to all 0. So basically int I equal to 0. We start with the counter I equal to 0, which 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 extends up to 150, which is our data size, and by each step I is incremented by 1. So now we will now we'll analyze each of the working of each of the blocks in detail in below code. So void setup is the Arduino based uh, block, which basically tells Arduino to run this code once. Void loop runs the code in a loop multiple times. It runs for infinite number of times. Serial begin 9600 gives us the baud rate, which is the number of bits transmitted to the Arduino and received received to the computer or processor. Void first let's start with the display. How are we displaying our signal? So like I uh, let me first negate the effect of all the filters or the code. So we would be just plotting the signal. So I will be commenting the filter blocks. The filter blocks or the working in the uh, blocks gives the dynamic programming in edge, and through this we are able to utilize the memory efficiently, as the memory size of our Arduino is very limited. So now I'm going to run the display loop to observe our original signal. So I'm going to upload the code. So it's done uploading. Now I'm going to plot the signal. So we can see that basically the signal has some peaks, and we are interested. Let me open it once again. I've saved it. So basically our signal has some peaks. These are the peaks, and we want to calculate this distance accurately, so that we are able to measure our heart rate or pulse rate. So now moving on to the code. So mm, now now we want move on to the display block of the code. So basically it has two input variables, which are ARR and Y. uh, which are taken from the our ARR is our original signal, original given signal, and Y we will compute, or the assessed version of the original signal or analyzed version. We can also call Y as the we would perform some operations on ARR array, and then we will obtain Y, and we will plot these signals simultaneously to observe what's the difference between the two. So let's proceed. We observed the original signal. Now we'll pass the signal to the moving average filter. So moving average filter, this is the code. This is the code for moving average filter, which would be given here. So the moving average filter takes two inputs. One is the see one is the array itself, this array, which has 150 elements each, 150 elements, and L is the window size of our moving average filter, which will be which is a global variable and is defined at the top. So now moving on the moving average filter. So basically we want so basically we can now see how a moving average filter works. So for int I, we will define an I, which is a counter int I. Now for I equal to 0, less than data size, which is 150, and I plus 1, we will increase it by 1. So now we want to calculate. So if say if L value is 3, so these this whole array of, say this is array, this is our given array, and we want to obtain this array. This is after we have performed the operation of moving average filter. So now for I equal to 0, this will so through this code up till this start over here and end still here. So up till this loop, we want what we want to do is, we if L equal to 3, or up till the counter reaches L, we want to take the average of those bits in this in the new created array. So this element would be here, and average of these two will be here, average of these three will be here. Then after that, when L equal to 3, if our L would have been equal to 3, then after that, for this equation, it would always calculate the average of 3 and place it to the bottom array. So if here, it will calculate the average of these three past values and the present values and place it here, and here it calculates the average of these values and place it here. So for doing that, what we have used is, if I minus L is less than 0, basically for if the counter is less than 3, and while we have defined a new variable j, and j would be defined as 0, as I equal to 0, first this condition would always be true for the first I equal to 0, and then in j would be initialized to 0, and then so I minus j would be always greater than minus 1 initially, and then basically this is the adding of these two elements. If j is less than I, and then basically we would be taking the average of these three or these two, and if these two, then placing it in, dividing by j and placing in this element, divide by 3 and placing in this element. If for this experiment our L is 5, so we'll be proceeding as we'll be placing this element here as it is, dividing this two element, adding these elements and dividing it by 2 and placing it here, adding these three elements and dividing it by 3 and placing here. So this sums it up till here. This is the case as I minus L is less than 0. This condition is satisfied as after each placement j is incremented by 1, and the final result is divided by j. Now we can move on the later cases where we have the counter has proceeded the initial L value, and we observe that through this equation I yi equal to yi minus 1 plus array 1 is the new array which we defined new array. It's the array 1 would be the new array. So uh, array 1 we captured. Array 1 is the array on moving average filter which we captured from moving average filter, and this is the given array. And yi is the array which would be modified, which is yi is the global variable which would be modified for the whole of the code for the further proceeding for the further processing for the further signal processing. Now moving on to this code, this line. So basically we are taking the average of the elements up till L and dividing it by the L. So basically we are averaging. So after say this element, if L equal to 3, we'll be averaging, we're taking these 3 elements and averaging it over here. So moving on to our code. Now we have now after performing the moving average filter operation, on our initial code, we can observe that our signal will look something like this. So this is our original signal, and after performing on operation of moving average filter, our signal will look like this, which will have remove which after, as we can observe from this signal, we are able to remove the high frequency components of noise from this signal. Now moving forward, so now I'll be explaining about the first order derivative function, which is given over here. So in this function, um, we are taking the input as y. So this is our input. uh, let's observe here, this is y. So basically the new changed array, this would be our changed array, and on this array our next signal processing would be performed. Further signal processing would be performed on this array. So now we would be we'd be taking the first order derivative of that function. So basically first order derivative can be for digital domain can be defined as the difference elements, which can be given by yi equal to y my I minus y I minus I my I component minus ith element minus I minus 1th element. So now moving forward, say